الآن مع المهندس عبدالله محمد المداوي. عنوان الورقة أو تحسين طريقة استبدال التربة بالضغط بالاهتزاز. سعادة المهندس عبدالله حاصل على درجة البكالوريوس في الهندسة المدنية من جامعة الملك فهد للبترول والمعادن، مهندس مشاريع، خبرة تتجاوز 10 سنوات في إدارة المشاريع في أرامكو. فليتفضل.
يعطيكم العافية جميعا. السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف خلق الله. أخوكم عبدالله مداوي من شركة أرامكو السعودية. في البداية أود أن أشكر حضوركم الكريم، وأشكر الهيئة السعودية للمهندسين على تنظيمها هذا المؤتمر، وأشكر وزارة الشؤون البلدية والقروية والإسكان على الرعاية الكريمة. في الحقيقة المؤتمر هذا هو فرصة لنا جميعا لتبادل الخبرات وتشارك التحديات والحلول. If you allow me, I'll speak in English as my presentation has many technical terms that I couldn't translate it accurately in Arabic. But luckily, the first word of my presentation is an Arabic word, which is sabkha. Sabkha is an Arabic term, has been used widely in different English literature when they describe the salt flat. So my presentation is sabkha soil improvement utilizing stone columns. This is a case study was applied on communication tower project in Saudi Aramco in Eastern Province. This paper was presented by me and Dr. Hassan Abbas from Prince Migrin bin Abdulaziz University in Al-Madinah Munawwara. I divided my presentation into 3 parts. First, I'll talk about, give you a brief description about our project and some general characteristics of sabkha. After that, I'll move to soil improvement, where I'll share with you the subsoil conditions that we had, what are the alternatives to improve the soil conditions, and I'll conclude with the results for the test that we conducted to verify the improvement on the soil conditions. As you can see here, the communication tower this is a simple structure. However, it is critical for our operation, for the day-to-day activities that is conducted by, that our operators conduct on daily basis. They use it also during emergency response plan. So we need to build such a structure with high reliability. The project is located in Eastern Province. It is inside a plant. This plant was built originally on sabkha soil. It has been built on backfill of sand. What are the general characteristics of sabkha? Sabkha exists in flat places and contains high concentration of salt. This will result into 2 things. Having the salt, the salt is sensitive to water. The salt will be dissolved in water, so this will cause differential settlement. And as a result of that, this will cause also a reduction in the bearing capacity. So this is 2 factors that will be threatening the safety of the structure. Moving to soil improvement, so as introduced to you, it is communication tower located in Eastern Province, was built inside gas plant, which is originally built on backfill of sand. Now we'll go to soil improvement. We conducted soil investigation test. We drilled 3 boreholes up to 50-meter depth, and we also conducted 2 basic cone penetration test and cone penetration test. I avoid sharing with you some tables. It will be confusing. However, I chose some charts, as you can see here. This is cone penetration test and standard penetration test. But to summarize the soil profile, I summarized it into the few lines, as you can see. From 0 to 3 meters, we have medium to loose sand with silt layers. This is the backfill area layers. From 3 to 13 meter, we have a very soft, compressible subha layers. And from 13 to 50 meter, we have strata layers with medium to very dense density. If you can observe on the 3 columns in the middle here, we have 3 bore holes. Those 3 bore holes represent the profile, and the drilling profiles were varied in each borehole. This is one of subha characteristics, which is the sudden change in the chemical and physical conditions vertically and horizontally. So it is unpredictable. Going to the foundation system, our geotechnical engineer has specified minimum of 200 kilopascal bearing capacity to carry the raft foundation. However, the existing condition, we have 85 to 145 kilopascal bearing capacity. What are the options that we had? At that time, we considered either to have file deep foundation to reach the stable soil layers, which is located 13 plus, or we do improvement that should be carried out for the subha layer, which is located from 0 to 13. We did some cost analysis, and we ended up that having the soil improvement with stone columns approach is more efficient in this particular project. It is the best technique due to its flexibility with soil type, depth of improvement, cost, and time as well. This is some general figures of the design. We drilled around 170 stone column on an area 17 by 17. The diameter, I do remember, it is around 1 meter. We drill it up to 15 meter in depth. This is top view and section view, and this is a comprehensive photo showing the foundation top of it. So, as you can see, we consider the stone columns, installation of stone columns with vibro compaction. And moving to the results and conclusion, we did 2 tests to verify the improvement and the soil condition for the improved soil. From 0 to 3, we noticed slight improvement in the sand with silt layers. Here I have 2 figures, the improvement factor and cone penetration test. Improvement factor, this is a formula that has been developed earlier to compare the pre-cone penetration test with the post ones. And on the left, it shows the cone resistance. The red line shows the pre-one, before the improvement. It was observed that some of the pre-cone penetration tests values are greater than the post one, which should not be the case. However, this I call it noise in the data, has been explained by Dr. Abbas' hypothesis in 2015 that this is due to a disruption of the cemented soil bounding during the wet vibro replacement activities, also the lack of surface confinement. However, the depth of the refusal point in the post-CBT test decreased by more than 5 meters, which is a good indication. We conducted also footing load test as per the American Society testing for materials. We need to apply 1.5 of the applied load, which is 300. Also, we applied 200, and the result of the settlement was 2.45, which is great improvement compared to the acceptance criteria, which is 25 millimeter. What we can conclude out of this, that the installation of vibrostone columns result in significant improvement. When I say significant, I'm comparing it to the subha soil. In the sand layer above subha compared to the improvement in the subha layer, stone columns are well-established ground improvement technique that has proven to be efficient in improving the bearing capacity and decrease the post-construction settlement in subha soil. We don't forget that it is critical that stone column spacing, depth, to be optimized in order to maximize the benefit of this method. This is general conclusion for such type of structure. I mean, communication lattice towers in general, be it transmission lines or communication tower, that some construction agencies tend not to take more samples due to having those structure built in a standard way, in series way. So they are not considering taking more samples due to save time and cost. However, soil investigation cost is less than 1% of the whole structure cost. This is negligible when it comes to the value that it provides. It provides reliability, it clears uncertainty about the structure, especially that those type of structure are critical structure. It provides electrical or communication. What you can carry out of this presentation, that we need to think about using recycled concrete to utilize it in construction industry. One example is to replace the stone columns, which the source of it is hard rocks, which is natural resource, to replace it with the recycled concrete to save the environment and follow the sustainable procedure. شكرا لاستماعكم، يعطيكم العافية.
شكرا مهندس عبد الله. حقيقة يعني ورقة يعني فعلا وحالة تستاهل الدراسة. هذه صبغها ومشاكلها منتشرة عندنا في المملكة، وتحتاج صراحة دراسات زي هذه، خاصة على الساحل البحر الأحمر بكثرة. فشكرا لك.